Hi students, I am very glad to share this topic to you students. I think so you are very interested to listen this class and all. I think so my past videos and all you are referred and you have some idea about this topic. And this is the continuation for the algorithm strategy unit number 4. Last classes we saw the what is meant by algorithm. What is the methodology of algorithms, how we want to write the algorithm and all, we saw the last classes. Today we are going to see about the complexity of an algorithm, how the algorithm is going to find whether it is easy, what are the factors are involved in it, how it is going to analyze. These are the things we are going to study in this chapter now in this session. See, the first thing is the complexity of an algorithm, the time factor and the space factor. The time factor which is determines that the algorithm which is takes the number of comparisons to take to sort an algorithm. See, normally we are having lot of algorithms to complete the process for each and everything. So, how many what are the iteration steps it is needed to complete the process, that is the main thing, that is called a time factor. And another one is the space factor. The space factor which is determine that the maximum number of space is required to done the process. For example, the algorithm is a step-by-step process to complete the specific task, that is called the algorithm. For we are writing the algorithm for any process, we can write the algorithm. As I said the previous classes, the likewise we are having the time complexity. The time complexity is nothing but the number of steps needed to run an algorithm in and to complete the process, that is called a time complexity. The second one is the space complexity. The amount of memory it is needed to complete the process, that is called a space complexity. And one more thing is that in order to overcome these things and all, we need two components are involved in it, which is explains that. So that is called a variable part and another one is a fixed part. The variable part which is explained that, so what are the variables and what are the constants we may use in those algorithms and all, what are the space are included in it, and one thing. And second thing is a fixed part. The fixed part which is depends upon the problem. See how we are going to access the steps and what are the methodology we are used in it. These are all in the variable part. So these are the things are involved in the concepts of complexity of an algorithm. So normally the complexity of an algorithm we may calculate it by using these concepts only. The number one is time complexity and space complexity, and time we can conclude that what is going to define in this topic, the time complexity which is defined completely how much of time to require to complete the algorithm, what are the algorithms we are used in it, how much of time it is required to complete the steps, that is the thing. And space complexity which is explained is totally the memory space, how much we need to, what is the need of how much of needing the memory to save the process and to complete the process, that is the concepts are involved in. These are the things which is involved in that. See, our next topic is efficiency of an algorithm. The algorithm, how it's become so efficiency. The thing is, when the thing is very efficient means the way what type of algorithm we are used in it and how we can use that process. That is only it leads to the efficiency. The term efficiency, it is explained that how long we are using that process, how long it will take to complete the process, that is called efficiency. In this topic we are having three things: methods of determining the efficiency and time space trade-off and asymptotic notation. See, the methods of determining the efficiency. Okay, how I am going to find the efficiency of an algorithm? The thing, we are normally having the small things. If we calculate that one means we can easily identify that this algorithm is so efficient for this process. The thing is main, the speed. The speed of an algorithm. When you use this algorithm, we will get a fraction of second to complete the task. the speed of an algorithm, and what type of OS we are used in it, and what type of programming language we are used in it, and the oneness and what are the compilers we are used, how much of seconds it gives the results or else the output. So these are the things which are involved in it, which is determine that the efficiency of an algorithm. And then time space trade-off. Already I said that the time space trade-off, which is explained that purely which is depends upon the how many or else what is the needs of within the seconds the output will be, we will getting that. So these are the things which are involved in it. And the third one is very interesting thing. In this bound only we are going to find our algorithm is a best or worst. See, this is the thing, asymptotic notation. These are the notation which is purely explains that our algorithm is a best or worst case. Here big O method. So big O method, that is a big omega and big theta. The big O method is when if you analyze your algorithm, whether the results which is under of big O means that is a worst case of algorithm. It will take too much of time to complete the process, to complete the task. That is called a big O. And then next one is big omega, which is explains that upper bound of the limit and lower bound of the limit. Here we are having two bounds. The one is upper bound limit and lower bound limit. See, normally we are going to put the strategy for algorithm to run the process. If the algorithm, let us take that in x-axis and y-axis, our algorithms, it should be like this, means it will take too much of time to complete the process. So this is the upper bound, this is the lower bound. So our value should be in the limit of that. So our algorithm should be like this, means what will happen? So it will give the better result within the fraction of time. So it will take a time and it will complete the process as soon as possible. So that is the big omega. Whether the big theta, whether it is a big theta which is explained that, see, when the upper bound of the limit is equal to the lower bound of the limit, means our algorithm which is leads to give the better result. So these are the methods we are going to find whether our algorithm which gives a better result or not. So these are the main things which is involved in it to efficiency of an algorithm. So while concluding that the efficiency of an algorithm, if you want to conclude that, means these are the things or the factors are involved in it. Whether big O means worst case, whether big omega means the upper bound of the limit and lower bound of the limit, it should be not an equal, whether it is the best or worst, it is in dilemma conditions. Whether in theta means it is enough equalizes upper limit and the lower limit, upper bounded value is equal to lower bounded value. Whether it is equalizes means there is equal time of to complete the task. So these are the things which is involved in it. And the next topic is interesting topic, algorithm for searching technique. So here I am going to explain the searching techniques, how I am going to search the value by using some more techniques in it. First we are having for searching techniques, linear search and binary search and all we are having. See, now we are going to see the linear search. So in this linear search, it is another name we are having in it, that is a sequential search. And here to find a particular value, so in this technique I am going to find the particular value in it, where it is, by using some more algorithm and steps. That is the steps we are going to see in this year. And while doing this some more steps in this searching technique, the list need not to be an order. Whether it is a shuffle also no problem in it. We will search the value. See, let us take a good example. See, input value equal to, we have some value, whatever it may be. Our system is going to search the value, our whatever we are needed. See, our target value is 65. Before moving to this, we should want to know the index value and value. Index, normally the index value, See 0, 1, 2, 3. Our system will take the value like this, zeros only. 0, 1, 2, 3, 4 like that only. And then the values are in increment 5 here. 5 placed to be here and 34, and here it is 65, and here it is 2, and here it is 71. It should be placed here. So this is the index value. See, by using this value only, we are going to calculate the where the 65 it is placed in it. These are the index value. See, output, we are going to find the output here. See, these are the indexes. Our target value is 65. Where it is placed? Here is 65 placed? No. Here impossible. So here only place. What is the index value? 2. So our output is 2. This is a method to find the linear search to find the value, because this is a sequential search. Here the list it is not in ordered. Whether it is in the list need not to be in ordered. So because of that only the list should be in shuffled. Okay. Our target value is 65. It is in the list. Whether I am going to check the value like 100. Whether it is a list. Okay, shall we found 0 index holding the 5, and 1 is a 34, 2 is a 65, 3 is a 12, and 4 is a 71. So our target value is 100. It is not there. So what is the result? There is no. So minus 1 bounded. Our value it is not there. So this is the thing. So our searched value it is not there means it will come minus 1. Our search target value it is not there. So once if you are searched like this means we will get the target value like this only. So I think so these 3 topics you are very cleared in it. Now we are going to see the next topic. Now we are going to see the binary search. Last classes we saw the linear search. Now we are going to see the linear search, that is a sequential search. In the list need not to be ordered in it. We can search the element by using the index value. But in this method we are using some more formula. By using that formula only we are going to define the value binary. So the name itself binary means by means 2. So here we are using the searching algorithm techniques called off interval search algorithm. We can say the binary search algorithm. The another name is off interval search algorithm. Here we are using the technique called divide and conquer technique. What is meant by divide and conquer algorithm? That is the algorithm only we are going to define here. First, if I am having the list like this, first I am going to separate the list. Then I am going to make the search in it whether our searched element is there or not. Because see, normally if I want to search the element in the list, the easiest way is if you are having the 10 elements, that is not a problem. I can easily search the element where it is. Whether I am having the plenty of elements is there, lot of list data is there means it is very difficult. It is very tough and also difficult to search a value in that. So because of that we are using here divide and conquer technique algorithm. See what I am going to give in this session. The algorithm is, see, now this is a list. In this list I am going to split the value. See, splitting the value it is not easiest one. We are having some formula. By using that formula only we are able to split the value. See the step 1. See, we are having the formula mid is equal to low plus I minus of low, which is divided by 2. This is the formula. So this is the formula to find the mid value. After finding the mid value only I am going to divide the value. This is called divide and conquer of algorithm. Then only I am going to implement the algorithm there. What is the value I am going to search here? Let us consider our value of searching element is a 60. Now I am going to find the value of 60. So what are the steps I am going to make in it? See the first step. Here I am going to find the low value. What is the low value? Obviously 0 is the low value. What is the high value? 9. This is the high value. See, low value is a 0, high value is a 9 and low value is 0. So 9 minus 0, I got the 9. 9 divided by 2, I got 4.5. See, 2, here it is 9. So already we know that 2 4s are 8. So remaining 1. So we don't have the sufficient value. So I want to put point here and I will put the 0 here, and 2 5s are 10. I will get the remainder is 0. So what is the value? 4.5. So 4.5 plus 0 is a 4.5 only. So that's why I will put the 4.5. Our system, it is not able to read the pointed value. So because of that, it will took the value only the round value is the 4. Now our mid value is the 4. See, our mid value is the 4. So this is our mid value. This is our searching element 50. Whether it is right? No. So I am going to the next step. How? Right side move. Because I am going to move in the sessions ascending order only it may execute. See here, if we want to move there means our fourth value, here the fourth value is a 50. Our searching element is a 60, which is less or greater. So I am going to search here low. Low equal to mid plus 1. What is our mid value? At last we found 4. So 4 plus 1, 5. So this is a step. Now I am going to find the next step, the step 2. I am going to select the sessions. Which one is here? I got the value here 5. So here what is the 5 is holding the value of 60. So I took the value, this is alone here, and I put here. So 60, 70, 80. Here I am going to find the value of low value and the high value. So what is the low value? Here I am having, obviously 5 is a low value and the high value is a 9. So already I have the formula low plus I minus of low, which is and divided by 2. So I want to substitute here, and 9 minus of 5, 4, 4 by 2. Here I am having the value of 2. So 5 plus 2, 7. So now I am having the mid value of 7. So 7 it is here. 7 holding the value of 80. This is our target value of 60. No. So again I am going to search the value. So 80 is a high value. So because of that, high is equal to mid of minus 1. So what is the mid value? At last I found the value of 7. So 7 minus 1 is a 6. Now I am having the value of 6. See here, what is the value of 6 here? It is holding of 70. So this is my value, this is my target value. No. So I am going to use the formula of low plus I minus 1. What is the low value in it? Because these two values only we are having 60 holding the value of 5. Okay, and 70 holding the value of 6. So what is the low value here? 5. What is high value here? What is high value? 6. So like this, 6 minus 5, 1 by 2. So when we calculate the value of 1 by 2, we got it 2 of 1. So it is not sufficient to divide the value. Because of that, I will put point here and I will put 0 and 5. 2 5s are 10. So finally I got the value. Whether it is 0.5. 5 plus 0.5, I got 5.5. Our system will never take the value of pointed value. So because of that, I will took the value of 5. So this is the final value of 5. Now we are going to, our system is going to search. Our value of 5 is there. Yes, our value of 5, which is contains of 60. Yes, our target value also 60. We searched here. When we compare with that last topic, we saw the linear search. We will take each element we are going to search, whether it is there or not, whether it is there or not. We are completely search the indexes values and all. So it will take too much of steps to conclude the value. When we compare this method, it is easiest method. Only the step 1, step 2, step 3. Within the step 3, we got the answer. Whether if we use that the linear method means our system will take the value. First it is going to check the value here and then here and so on like this, because how many steps this goes to for linear searching? When we compare with the linear search, step 1, step 2, step 3, 4, 5, 6. Step 6 only we got the answer in the linear search, but in the binary search we got the answer step 3 itself. So this is a conclusion. These the two algorithms we are using in it. When compared with the linear search, binary search only, it will give the better result. That is called divide and conquer algorithm we are used here. These are the techniques we are used to search the value. I hope you are very cleared in this topic. Please subscribe to our channel. Don't forget to click the bell icon. Thanks to everyone.